Hello, my name is Mr. Springer. I've taught chemistry for about 25 years now, and I put together some YouTube videos to just kind of help clarify some topics that may be a little more complicated for some people. Um, I like to keep things simple, and there's no point in making things more complicated than they have to be. This was started out as a blank periodic table, and I've written on the symbols for a few elements. The ones that I find to be most useful in a chemistry class in high school and possibly even in college for that matter. I've written in above each column. Most periodic tables will have at the top of each column a number with an A on these taller columns. These are called the representative elements. So we've got the first column is 1A, the second is 2A, 3, 4, 5, 6, 7, and 8A to keep track of those columns. Now it's a kind of a nice thing because that A group number also tells us the number of valence electrons that atoms in each of those columns have. Valence electrons, you may or may not know, are the electrons involved in chemical bonding. And so atoms can either gain valence electrons or give away valence electrons or can share those valence electrons in order to make chemical bonds. The goal basically of this whole bonding thing is to get a set of 8 valence electrons, which is called an octet. Because once an atom has an octet of valence electrons, electronically it is stable. Some things happen to it chemically in the process, but at least in terms of the number of electrons, it has its full set of valence electrons. And those that have a full set naturally of 8 valence electrons, have an octet naturally, are these out here in group 8A, which we typically call the noble gases. Now, helium is a slightly different. I colored it red instead of black because helium, even though it's in group 8A, only has 2 valence electrons because it's only got one orbital that it can put valence electrons in. And you may or may not know that an orbital describes at most 2 electrons. So helium, even though it only has 2, is considered to be a full set of valence electrons for that atom. Since we're trying to get to 8, elements in groups 5A, 6A, 7A, very close to 8, they just need to gain very few electrons in order to get there. In fact, elements in group 7A just need 1 electron. If they gain that 1 electron, they will have 1 more electron than they have protons. A neutral atom will have the same number of protons and electrons. So if we've gained an electron, we now have 1 additional negatively charged electron, which causes elements in that column to have a charge as an ion of -1. Fluorine, the atom, has no charge, but fluoride ion has a charge of -1. So once it gains that electron, it becomes an ion and has a charge. Oxygen and sulfur and any others in 6A, well, they need to gain 2 electrons, and when they gain their 2, they end up with a charge of -2. Elements in group 5A, well, they need to gain 3. When they've gained 3 electrons, that gives them 3 additional negative charges that the neutral atom of nitrogen or phosphorus or arsenic do not have. So once they've gained those 3 additional valence electrons, we'll have a -3 charge. I'm going to skip over 4A for right now. On this other side, the first column, well, they would either need to gain 7 if they want to get to the end of their row, like sodium would need to gain 7 in order to have the same electrons as argon out here in group 8A. But if it could give 1 away, then it would move back down 1 and would put it here where neon is on the periodic table. Then it would have its full set of 8. So you may want to lose an electron. Those in the first column tend to want to lose an electron, and when they lose 1, now they have 1 fewer negative charge, 1 fewer electron than protons, So they end up with a charge of +1 because of that one fewer electron. The ones in the second column, well, they need to give up 2. When they give up 2, they end up with a charge of +2. The column 3A here, that's the boron column. Aluminum being the main one that we use in that column, would need to need to lose 3 electrons. Give up 3. Once it's given up 3 electrons, it now has a charge of +3. Group 4A, it could gain 4, it could lose 4. Just depends on what it's with, basically, whether it gains or loses. So I usually put a plus or -4 above that column. Typically, metals, which are things on this side of the table, will lose electrons or give away electrons, and nonmetals, which are on this side, tend to gain electrons. So in the process of gaining or losing electrons in this way, these atoms are becoming ions. An ion is an atom with a positive or negative charge, depending on whether it's gained or lost electrons. And then what happens is positively charged ions and negatively charged ions will attract one another. Even though they've gotten their noble gas configuration, which means they're electronically stable, they can't help but attract one another because of the different charges that they have. So that's a little bit about ionic bonding. In terms of valence electrons and how that all works out on the periodic table. The ones here in the middle, in the B columns, so they do some funny things with their valence electrons. Sometimes they can move electrons around and have either more or fewer valence electrons than otherwise would be possible. I will tell you, though, that zinc, every time I've ever seen zinc as an ion, it's been a +2. Is it possible there are other zinc ions out there? I guess it's possible. Never seen one. Silver is always a +1 ion. +1. Copper can be +1 or +2. And iron can be +2 or +3. Most of these out here in the middle, which are what we call the transition metals, can have multiple charges. So some of those you just have to memorize. But these out here in the representative, the A groups, you can pretty much tell what they're going to be by their location on the periodic table. So whenever I teach chemistry, one of the first things I do in class in August, I'll hand out a periodic table. Usually it's one that looks just like this one. And I have them put the pluses and minuses at the top of the column on the first day. And we also circle hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. I have them circle those 7 elements on the first day as well. And we make a note that the circle means that these atoms form diatomic molecules. They're elements. You don't ever have just a hydrogen atom. It's going to be a hydrogen molecule, H2. Same way with nitrogen would be N2, oxygen would be O2, fluorine would be F2, and so on. Those are always, when they're not ions, when they're not in a compound, they always are in sets of 2. So that kind of wraps up this first video that I'm going to make here, and I appreciate your time, and thank you very much.